So I'm going to show you how to weigh out the sodium chloride. The best thing to use is a small beaker, something like this, rather than a watch glass. So put it on the scale, but don't tear it out. Take note of the mass of the beaker as being, in this case, 31.37 grams, and write that down in your lab notebook. Now, a lot of the time when people want to add material to something like this, they'll leave it on the scale. They'll do something like this. Now, this is fraught with risk, because what's going to happen is a lot of this, or some of it at least, is going to end up on the balance and will get under the balance and end up ruining a very expensive balance. So these are very expensive pieces of equipment, and we want to preserve them as much as we possibly can. So what I want you to do, if you wanted between 4 and 5 grams, and that's probably what you want in this lab. I know it says between 2 and 5 in the lab manual, but in order to maximize your significant figures, I think between 4 and 5 is going to be optimal for you. If we know that we've got 31.36 grams for the beaker and we need about 4 grams, so I'm going to add 4 grams to that, so I know I need about 35.36 or more in this beaker. So what I'll do, in order to put the sodium chloride in, I'll take it off the scale, and then I will add the material to the beaker. So as you can see, I'm even making a little bit of a mess here. Can you imagine how this would be if I was actually doing this on the scale? So I take that off, I put it here, and I can see I'm at 32.84 grams. So I know I'm at about 1.5 grams. I'm going to need about 3 to 4 times more what I've got in there. So that's how I can eyeball how much I need. So I'm at 35.21, that's still a little bit short of what I want. .05, that's not too bad, that's okay. So that is within the range of what I want to have for the sodium chloride. Now what I will do then, the best thing to do to get the most accurate amount of exactly how much I've added, is I'll take this away now. I'll pour it into whatever I need to pour it into, and then I will reweigh the beaker, and this will take account of any residue that's here. It turns out it's the same, so it really hasn't been any real loss here. So you can just mark that down on your lab notebook, and obviously the difference between what you had initially and the empty beaker with the residue in it will be the mass of sodium chloride that was added to your solution. So what we're going to do now is we're going to put ice into this cup, and the directions it says to pretty much fill the cup up with ice. Would you please do that, Samuel? So I think about 95% is what it says in the directions. There we go, that'll probably do it. So would you mind showing that to the camera? There we go. Nice. Okay. Now we're going to add water to it. And just fill it to close to the top, right? Right. Now we're going to take the temperature of this ice water using a thermometer. Alright, I'm going to show that. Alright, so once that temperature has stabilized, in the directions it says record the lowest temperature even if it goes back up again. So that's been done here. So go ahead and take the thermometer out. Sorry. And we can go ahead and pour the salt in. Alright, so we weighed the salt earlier, and the best solution here will be to go ahead and reweigh that beaker so we can take account of the residue. That's what I showed you earlier. Alright, so now what Samuel's doing is just going ahead and stirring it. It's better to stir with a stirring rod than it is with the thermometer. The thermometer is kind of sharp. There is a risk that you will pop the container. It's a better technique to use a stirring rod rather than a thermometer to do the stirring here. Alright, so in the directions it says to stir it until the salt dissolves. It's not really going to be possible to see the salt dissolve in that cup with the ice and everything in it. But we put the thermometer back in now once we've done that, and we're looking to again record the lowest temperature that we can obtain here, which will be less than what we started with before we added the salt. So even if the temperature goes back up, what you're interested in again is just getting that lowest possible temperature. The hope is that it's more than or less than minus 1.0 degrees that it goes down to, because this will maximize the number of significant figures that you'll be able to use here. So it's just going to be a matter of time. Take that lowest temperature and then you'll be done. Right, before we do anything, we do need to weigh the beaker that we're going to pour the salt solution into, and there it is there. So you should tare it first and then put the beaker on and then weigh it. So Samuel's going to take the thermometer and the stirring rod out now that we've got the lowest temperature that we can get here. Now this beaker here, this beaker over here, has been pre-weighed. Put a piece of gauze mat on top of it, and now we're going to filter the ice out of the solution. Now you can see the technique he's using. He's kind of pinching the cup a little bit, and pour fairly quickly so you don't lose a bunch of the water. That's really important. You try and get all the water out that you can. Now he's already put a bit of ice on there. Now it's kind of filling up, so he's going to take that ice and he's going to put it in the sink. There we go. Then he continues. There we are. Yeah, the most important thing is to try and get all the liquid water that you can out of that. And just one more to get the residue out. Okay. There you go. Alright, done. Okay. So now we are going to, Samuel's tearing the balance here, and he's got his beaker with the salt water solution in there, and he's reweighing that.